Hi, so today we are doing an Alkyne problem for OrgoChemSimplified. And what we are doing is a synthesis problem. And we're asked, how do we go from this compound to this compound using any reagents we want? Well, let's think about it. 1, 2, 3, 4, 5, 6, 7, 8 carbons. This has 8 carbons. This has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So we need to extend the carbon chain by 1. Right? And we want to tack on this extra carbon. So how are we going to do that? Well, the easiest way to do that is a nucleophilic reaction. And what we know is that this hydrogen, because it is an attached to an sp carbon, it has a pKa of roughly 25. And so what we can do is we can deprotonate that using a strong base. So I'll take NaNH2, which is essentially the same as NH2 minus. And that's going to have a pKa of roughly 38. Okay, so if we use NaNH2, we're going to deprotonate that proton. Okay, so now we have this compound, and we have this negative charge, and so the lone pair, we want to use this lone pair as a nucleophile. And once we use that lone pair as a nucleophile, we want to attach another carbon. So we want another carbon. Well, in order to have a nucleophilic reaction, we're going to need a leaving group. And the best leaving group is probably, you could use iodine, but I'm just going to use bromine. So bromine, and I'll drop on there, and then H3. Okay, so carbon needs 4 bonds, so you have a bromide and 3 hydrogens. We know this, we want that to be an SN2 reaction in terms of this lone pair is going to attack that carbon, and this bond is going to break, and Br minus is going to leave. Now that's going to give us the next reagent, which is 1, 2, 3, 4, 5, 6, 1, 2, 3. Right. So that's almost the product we want. Right. So the next thing to notice is that we're going from an alkyne, which has 3 bonds, to an alkene, which has 2 bonds. But what is the configuration about this double bond? It's not a trans, it's a cis relationship. And for cis relationships, we know to go from an alkyne to a cis alkene, we use Lindlar's catalyst. And H2. Don't forget the H2, because otherwise you won't have protons to add, and your answer won't be correct. So once we use Lindlar's catalyst and H2, we are going to get our product. So just count the number of carbons, figure out how I need the steps I need to take to go from where I am to where I want to be. So I know I needed to add on a carbon, and the easiest way to do that was deprotonate the hydrogen and use it as a nucleophile. And once I knew that, I was able to say, hey, I needed a cis alkene from an alkyne, so I know that Lindlar's catalyst does that. And I didn't forget my hydrogen. So yeah, that's how you do a synthesis problem. You just say, where am I? Where do I need to go? What bonds do I need to form? What type of reagents do I need to use to go from this type of molecule to that type of molecule. So hopefully that helped you figure out the thought process for a synthesis problem. And if it helped, leave a comment, like the video, and thanks for watching.